All right, let's come back to our first example. Hello. Yeah. Cool. So now a really obvious problem about this is like, okay, yeah, we are seeing the points. We want to see the original geometry, the grid. So let's solve that already. So later we don't have to think about that. How we can do that? Well, can bring again our original geo, and we can just do a sample nearest. All right, which geometry? Well, I wanna find it from the points. All right, and now this is the index. So now sample index. All right, which attribute? This is basically a transfer attribute, but just like I feel that is extremely complicated. But anyway, temperature index, and now, yeah, and now we can store named attribute, and obviously in the original geometry, and I'm going to call it again temperature, and hopefully there we have it. We have transferred the attribute. As I said before, basically this is just a way of transferring attributes from here to here. All right. Basically, you sample the nearest position, the nearest point to the grid geometry. You get the index, then you get the attribute of that index, and then you just pass it to your geometry. So I'm just going to call it this part attribute transfer. And I'm not super happy with this part, it's not super smooth, but what we can do now is smooth it out, because okay, let's see. You can see here like it's not completely exact what is going on, because obviously like we are just doing an approximation. So now what I'm going to do is blur the temperature. All right, temperature, and I'm going to blur it. Blur attribute. And now if I visualize this, you see that all those irregularities are gone. For now, one iteration is good. Also, it's going to make the simulation faster. Well, the simulation, this is post-simulation, but you know what I mean. By the way, it's really useful to have here the timings. So if you see here, I put like 20 here, it's going to make it slower. So just keep it. See here. Sorry, 0.74 milliseconds. One is much less. So yeah, just take that into account. And I'm now grouping this, and it's attribute blur. Attribute blur. Cool. So now let's make this a bit less boring. Let's focus first on how to control the speed of this spread effect, because now it's going to, like, maybe for you it's fine, but maybe it's going slow, or you want it faster. How can you do that? Well, one first solution is change the fuel. Put the fuel to 0.1. You know, it's going to need more time to reach the value of 1. I'm going to now, because I'm work with different timings, I'm going to increase the frames. So you can see now, you know, that this needs more time to get warm. But still, you know, the temperature that is greater than 0 is spreading at the same speed. So we don't want that. I mean, we want to control that. How we can control that? Well, we can do here is when we split the geometry in two parts. Instead of like when the temperature is greater than 0, well, I can just do compare greater than 0.5. All right, and let's see what happens now. Now, if these points really need to warm before they are taken into consideration, they need to reach the value of 0.5 to enter in this separate geometry. Yeah? So now this is what is actually going to make it slower. Yeah? So now, basically, there are these parameters that are going to really play a lot how fast this is going to be. That is the fuel and the, let's say, the limit temperature. Okay? Now, if I will put here 0.1, you are going to see that it's going to be much faster. I recommend you to start to already collecting the most important parameters. And yeah, I'm just going to call this limit. Okay, so now that we have controlled the speed of the spread, so it would be nice to add a bit of noise on how the temperature is spreading, because now you can see it is almost like a circle. It's pretty boring, and it would be a circle if the scattering of the points would be perfect. But it's not so. There is a bit of randomization there, but it's not enough. Let's store name attribute at the starting. As I said, it's very important, like that we have at the starting some attributes to work with, and it's going to be how is called it? Noise temp. I don't know, and we are going to say noise texture. Plap. It's connected here. Yeah, and let's plug position. By the way, what I did right now is I press Q and I have quick favorites, and I use some nodes that I use a lot. If you want to do that, I think that you need to go to search nodes and, for example, imagine a store name attribute, and then you right click and add quick favorites. So now if I click here, store name attribute is here in my menu. If you want it to be safe, it happens to me all the time, you need to save preference. Now will be this will if I open Blender again, it will be here. So let's visualize, and you see here that we have some noise. I'm just going to maybe scale it down and maybe add a color ramp. Yeah, maybe a bit smaller and maybe a bit more interesting. I don't know, a bit more of detail and a bit more of roundness. Oh, something like this. So what I was saying is, like, if the starting temperature is here, right? Now, basically the spread will go in this direction. Yeah, and we'll avoid these parts. This will mean that these points are going to start, they are not going to change their temperature. Although what we can do is make this noise 4D. Obviously now change it, but anyway, just don't see this. Now, so basically, for example, now the noise is going to spread. Like this, right? And these ones are not going to be able, but then this is going to change, and now these ones are going to be able to spread. So you can see that. Sorry, I am editing now the video, and I'm just realizing that I made a mistake in this part. I'm just in a quick Blender file just to show you what I mean. I have just this cube over here, and imagine that I just wanna transform it in the simulation. Now if I click play, nothing happens, but imagine that I want to transform it, for example, like in the vertical direction, in the z-axis. So now, for example, let's plug the time and I just transform it, you will see that it starts to move. But if I will do this, so if I will plug it to the end, to the starting of the simulation, or if I would like store the attribute or whatever, doesn't really matter. You will plug it here, you will see that it doesn't work. that's why that's because what we plug into the simulation is a constant. So because the geometry is just kind of like looping through here, and what enters here is just when the time is equal 0. Okay, so that's a problem. So what I was doing before, it was not going to work because I was plugging a noise texture that is changing every frame. And yeah, I'm just going to take the first value of the noise texture, the one for W equals 0. So yeah, if you want to add that effect, so with this changing parameter, you will need to do it inside the simulation, not outside. Sorry about that. The value of the noise with the clamped with the color ramp to the store name attribute. So now that we have created this noise, how we can plug it into the simulation? So we randomize the spread speed and which areas are affected more or less. And I think that there are a lot of ways of doing this, but I feel that the simple one, or the one that I just think, is surface. No, I don't want that attribute. I want the noise temperature. Is just multiply the distance that we came at the starting, so the searching distance by this. So yeah. So if I just multiply by this attribute, some points will get more chances to be analyzed, and other ones will have less chances. So let's see now what happens. Well, nothing. Let me visualize the noise. Yeah. So this is something that I was thinking that could be a problem. That is like if the points where the noise is 0 are inside the starting group, the points around are never going to be analyzed. So we have to watch out with that. We can solve it just changing the value of the noise, or we can also kind of avoid the clamping to just go to 0. But I don't know. Let's just see what works better. Alright, so now you see that we have some kind of differential spread through the geometry. By the way, I changed the search radius to 0.08 because it was not kind of pumping at the starting. This is something that you need to always take into account in spread simulations, that sometimes it doesn't kick in and you need to change a couple of things. Starts to look more organic, right? If you would want, because now these parts are always going to be black, are never going to get warmer. But by the way, if we compare this with the noise, you're going to see that is the same pattern. You can see it here very well, but like you see, it's the same pattern as we had with the temperature. But anyway, if you would want this to change, that some certain areas getting warmer, like that these areas at the end get warmer, then what you can do is send time, and then just the seconds, just plug it here to this parameter, so then the noise change. We can quickly add that functionality. Can just multiply this here. Whoop. And this is going to be the noise W, and here also they just already plug. Cool. So now we have the randomness that we wanted. See? Let's visualize the final geometry, and there we have it. We have a spread solver. Let's test it in other geometries, for example in Susan. and let's see how it works. Always these noises depend on the geometry, so the result might change. But yeah, you can see that it's working. Maybe if I put this in 1000, we can see it better, and it's working in real time, so that's pretty nice. So now that we have something that is looking like a spread solver, it could be more complex, but I think that is already looking pretty good, and it has parameters that we can tweak to make it more interesting. I would like to invest a bit of time on how to push it a bit better in terms of definition. As you can see here, the resolution of the geometry is pretty low, so we have this kind of like boxy attributes. Yeah, you know, like this is not really smooth, and even with this attribute blur, we are not going to make this look better because the resolution, like the attributes, are stored per point or per primitive. So yeah, let's invest a bit of time on how to make it look a bit more high res, and then how to cache it, sending to shading and to render, and also compositing. Okay, so the way of making this look just more high res is just subdividing more. One way of doing this procedurally is just adding a subdivision surface at the starting, and now it's just going to look better. We have here like 1 and the render 2. Let's just try with 2 and see how it looks. And yeah, you can see here that now we have, at least from far away, we have a good terms of resolution. I always tend to put like here maybe 0, you know, to make it look nicer here, and then in the render 2. A big part of this simulation working is that the points that we are throwing to the simulation. If we will add like, just imagine like just only these points, the simulation would even not work. So it's important that we input the correct amount of data. For that, I think that it's nice to have a visualizer of the points that we are scattering just at the end. So doing that is pretty simple. We just need to add a switch node at the end and just connect the scatter points. So I'm just going to go like, so as you can see here, this switch will change between both the representations, and now I can just have it here and maybe call it visualize guide, and maybe I'm just put it here at the starting of the geometry node setup. That was just something quick to easily debug. Now let's continue. Let's talk a bit about caching this, because if we want to render it, it's recommended if we cache it. For doing that, is pretty simple. You just need to go here to the physics, and here you have simulation nodes, and you can bake. If you bake it, then you will save it to disk, and then yeah, let's just do that quickly. Bake. I am baking way too many frames. That's not recommended. But well, as you can see now, where I have my file, I have here a file cache with all the simulation. You can see here that is half a gigabyte of data. So watch out with how much data you are storing, because it can get a bit heavy. Now, also remember that once you have cached it, if I would like put here like a density of 0, so that shouldn't work, it's still going to be working because we are reading the data from the disk. If you would like to get it back working, you will need to just delete the bake.